Thank you very much, Julia. Thank you for this tip and thank you for the introduction. And also welcome from my side. And I'm happy to see that so many people are interested in my presentation of a new tool set within PLATO-1, which I'd like to show you right now. So first of all, I'm switching off my camera that you can fully concentrate on what I'm going to show you. And then I'm going to start. So why do we need a new method tool set within PLATO-1 regarding the topic special characteristics? When you are responsible to work with special characteristics or with characteristics, then you probably know these signs. So there are many different types of special characteristics from different companies, different OEMs make their own definitions and so on. So there is a lot of confusion around special characteristics. And most standards which we have to work according to, they require a systematic derivation of special characteristics, for example, by the FMEA or by other methods. But none of them says how to do this exactly. So it is not described how to work with these special characteristics. This leads to that every company creates its own procedures with different tools. For example, making an FMEA, deriving a control plan from it, but having special characteristics on a separate special characteristics form, for example, in an Excel tool or something like this. So this leads to a risk of inconsistency between the data, and at the end, if there are inconsistencies, this is leading to useless discussions and a lot of wasted time. So that's the situation very often, and I saw this situation also in the past in my work as an FMEA moderator. So I was really happy to have the chance to create such a procedure together with my colleagues here at PLATO. And yeah, what did we use? What is the basis for this method toolset I'm going to present to you? That's the standard from the VDA. There is a process description which describes how to identify, how to classify, and how to document special characteristics. And the idea in this standard is shown here on this slide. If you imagine a development process starting with the idea, then with the product development, then the process development, and at the end with the production of the product and delivery of the product to the customer, then the standard recommends to think in filters. And in these different phases of the product life cycle, they start with what they call a concept filter, hand over to a design filter. This is during the product development, and later in the process development, it continues with the production planning filter and the production process filter. Such a filter in detail is shown here on the right. Starts with an input. So the input is, let me say, the potential special characteristics now in the content of special characteristics. They are filled into the filter, and the first question which has to be answered is, do we have a robust concept, design, production concept, or production process? The question is depending on which filter we are talking about. So this represents all 4 filters here in one. If the question is yes, we have a robust concept, design, and so on, then we can filter out a characteristic. So this means this characteristic has not to be a special characteristic. If the answer is no, next question should be, of course, from engineering side, do we have a chance to make the concept, design, production concept, production process more robust, to make it, to change it, to make it more robust? If yes, then we have to go back, we have to do a loop. If no, the output is a potential special characteristic and forward it to the next filter level. And at the end, we have the final list of special characteristics here at the end for our control plan. So this is the idea of the VDA, but it's not described how to document these decisions and how to handle it. But the idea is a quite good one. And we have something similar in the Ford descriptions, where they talk about potential special characteristics, YCs, YS in the development phase, and later deriving SCs and CCs from them. So the idea is quite good, but how to handle it? Let's have a look on what we already have in PLATO-1ns. So our previous status is we have different methods. So we can start, for example, with the requirements tool, hand over to the design FMEA, go on with the process FMEA, and then we have here, and we link this data together in the control plan. So process steps and machines could be used for the control plan or assigned to the control plan, and then also the characteristics, the special characteristics, the externally defined ones, or the design characteristics or product characteristics from the D-FMEA, and the process characteristics from the P-FMEA. And this is all linked together in one data model. And this is one of the big advantages in the PLATO tool because of our data model, because our data model offers a characteristic or the datum characteristic parallel to the function. We are quite flexible on that and can really integrate all this information in one data model. And the idea now is that we add this filter idea to our tool set. Therefore, we added in 1ns methods a new form sheet called design SC and a form sheet called process SC. And these methods forms, they contain these filters. So now we don't need to have the direct connection between the module, the methods, and the control plan. We can put them into the filter, the external characteristics, the product characteristics here in the design phase, to the concept, and later the design filter. And then the process characteristics coming from the P-FMEA, in addition to this in the production planning filter and the process filter. And at the end of these 4 filters, the result is a defined list of special characteristics which can be used in the control plan. And not to forget, also the filtered result, a list or the filtered not special characteristics, which can be also used in the control plan if required. So this is the basic idea. And how does it look in the tool? I'll give you a presentation after my slides, but just to show you a few screens. We have here in 1ns methods now a new category called special characteristics. And there you can find the 3 form sheets: design SC for filtering the product characteristics in the design phase, process SC for filtering the product characteristics and the process characteristics during the process development, and the decision documentation SC, the 3rd form sheet, which contains a summary of all filter decisions, including a history showing all decisions during the time. This is a read-only form, but and contains this very important information, all summarized in one form. So this is a screenshot of the design SC form. I'm going to fill this together with you in a minute. We have here always on the left what we call the current state, and on the right a decision area. And you can see here characteristics like material and diameter. They are analyzed now in the context of a function. which is coming from the design FMEA. And on the right, you can see the decision with the history. And if you have a look now at these two product characteristics here, the material and the diameter, we can find them on the next form sheet on the process SC as well. Here we have them now assigned to a process step and analyzed it in this content. So again, current state and decision state, and you can see here now filter number 3 and 4, so the process filters with decisions, with documentations, and with history. I'll show you in the tool directly. Additionally to the product characteristics in this process SC form sheet, we also add the process characteristics, which come from the process FMEA, and we can also filter them. And both or all characteristics which are analyzed with this method toolset are then shown in this documentation, decision documentation form sheet, which is a summary of all decisions done with this method toolset. So the product characteristics and the process characteristics are shown here with all decisions, with all necessary information. So that's the quick overview. And now I'd like to step into the tool and show you how it works in a real project. So I'm now in PLATO 1ns. I already prepared a few tabs to be a bit faster now for the presentation, and I prepared a small example. I called it elevator. And just to have a look at the structure, I have the structure tree here. So the top element here is called elevator. And there we have two main structures. One is this elevator system. This is the design structure, and one is the elevator process. This is the process, or this contains the process FMEA of the elevator. These two structures, they are not linked to each other, or they don't have to be linked to each other. They are here in this below the same top element, but there is no other linkage between. No functional linkage, no structural linkage. These are two structures. This could be also even in two different projects, if you like. It can be, of course, also directly integrated. So as it is shown in some standards, to have the process below the product, something like this. I made the example here this way to show that we can have independent structures, independent design and process FMEA, because in reality, very often different teams or different companies work on design and or process FMEA, and therefore it is necessary to have this, to be able to handle this separately. So let's have a look at the design structure. We have this elevator system consisting of an hydraulic cylinder, a cabin, an elevator shaft, and a lot of other components which I don't want to have here. And the hydraulic cylinder is analyzed a bit more in detail here in my example. It's consisting of the piston rod, piston, cylinder housing, and so on. And down here, the structure of the process looks a bit different, or not different, easier. We have the process and overall element, where we created then the sub-process steps, the production of the hydraulic cylinder, production of the cabin, production of rails, and so on. And you can see only one sub-element here, or one M element here, which is the operator who delivers some failures for my FMEA later. We have an FMEA created, of course. In the real world, it should be a complete FMEA. In my small example, I just have an some FMEA content here for the hydraulic cylinder, and we'll show you here. So the hydraulic cylinder has some functions: buckling safety, leak tightness, lifting power. Has some failures: buckling safety not ensured, cylinder leaking, and so on. And these failures has effects on a higher level, so this is linked, and causes on a lower level. So diameter too small is a cause for a not ensured buckling safety. And when I go follow this link to the lower element, to the piston rod, then I can see I have something like a typical characteristics level, but I work with what I would call collecting elements for characteristics, like here the material properties, the radial dimensions, and here I have many specifications, or all the specifications which are relevant here from design side. So the material, the surface treatment, the surface hardness is linked to the material properties, the diameter, surface roughness is here linked to the radial dimensions. So this is important to understand what data is there, and in the context of the design FMEA, the example is quite small, of course. I also analyzed here a little bit with an imagined team, and found out that the risk is acceptable or medium in some stages. And yeah, this is the information from design side. And when I have a look at the process FMEA, this is on the third tab here, already opened, then I can see I have I made the FMEA here on the production of the hydraulic cylinder, and I have here the turning of the piston rod, grinding, and further process steps. And I can see here some process specifications, so cutting speed, feed rate, grain size, and so on. And then here also some failures with effects, with causes. And here I made a link between the process FMEA and the design FMEA, because if the diameter is wrong, the cylinder is leaking. So the failure net is linked through. What makes sense to have it all in the same failure net, but it's not necessary that our method Toolset works here. So this is the data which is available here in the process FMEA side. And now I'd like to step into this process with for the filtering of the special characteristics. So I start at the beginning. Remember the slide with the idea, the top element, this was then the production process. So I go there to my element where I make the design FMEA. This is the idea of this method. And I start my method. So I go to 1ns methods. I go to special characteristics, and there now to the design SC form sheet. And yeah, the connection to the design FMEA is shown here with the first 3 columns. So the common data is the function. So we have the 3 functions here: buckling, safety, leak tightness, generate lifting power. And then we decided to add 2 more columns from the design FMEA. That's the maximum severity. It is not linked to the function, but it's linked to the failures within the function. So, and it gives us an indication for the severity of the function itself. So a high severity, 10, is signal for this is potentially a safety relevant function. So we have this function, this column here, and we have the filter code here, which is a classification of the function, or a potential classification of the function. I have chosen a critical function here for the buckling safety, and we can use these columns here now for filtering the relevant from the more relevant from the not so relevant functions. So I can decide for which functions I like to do this filtering. We decided it makes sense. So in this example, we decided it makes sense to filter for the severity. So a function with the highest severity 6 in the failures below, that's not relevant for, in my opinion, for the further analysis of special characteristics. So I remove them and only focus on 8 and 10. So I can see I am working in a filtered form sheet now, and with only these 2 functions. And now I go on and with my collection of the relevant characteristics. So on the left side here, we have this current state, and this has to be filled, of course. So when I double click into this characteristics cell here, the tool now delivers all characteristics within the structure which are linked to this function. We are looking upwards and downwards in the function and the failure nets, and everywhere where we find a characteristic, we add it to this list. These are now specifications or characteristics which are linked to the function buckling safety. So that means that these are potentially safety relevant characteristics. So in my opinion, they are all potential special characteristics. That's why we implemented this select all button down here, to say I have to analyze them all. For the example now, I'm only going to choose the first two, the diameter and the material, and go on with only these two examples. I say apply, and in this moment, the tool takes the characteristic with the specification and the tolerance, and if there is already a classification, already this classification. So the current state is filled now for the first function, and I can go on now doing my decisions. So let's have a look at the first one. The material is already classified as a CC. Why? Because my customer said this has to be a CC. I don't ask for the reason why. I just accept it because customer is king. He pays for it. So this is an external classification. And I accept this and I document it here in my decision stage. When I tick this checkbox here, external class, an auto text is filled into this rational column where I can fill in a comment. I can edit this comment. The classification is added here as a new class. It's the same one, but I can also edit it. For example, some customers have different classifications, so you want to translate it into your internal classification, then you can comment it, change it here, define another classification, for example, and then at the end you can press apply, and this classification is applied again or assigned again to the characteristic material. But now we have an entry in our history here, so you can see the date, the time, who changed the classification from which value to which value, and you can also see a comment. Let's go on with the next characteristic, the diameter. So the team discusses about the 82 millimeters in the context of buckling safety, and they say, I have a safety factor of 10, larger than 10. So we all agree, we talk about a robust design. Once I've selected a robust design or robust concept, I can't assign a new class here. This is grayed out now, and I can say apply here. So for the diameter in the context of buckling safety, there is no need to assign a special characteristic. So we say apply. And again, an entry in the history is done here with the comment visible. All right, let's go on with the next function, leak tightness. And I also have to add the characteristics here. So I double click and I can see the diameter here. I select it and I said apply, but yeah, I want to add the other ones as well. But let me go back to the diameter. Sorry, this is the same diameter than above. So it has different functions. Of course, you can imagine regarding the buckling safety, that's the diameter is important, but also in the context of leak tightness. And that's why the diameter appears twice here. If I want to add further classifications here, I can do this. So I have here a leakage rate. This is a characteristic which is not coming from a single component. This is the leakage rate of the hydraulic cylinder. This is was noted and added in the FMEA form sheet of or on the FMEA level, not on the characteristics level. I can assign this as well, and the surface roughness. I apply it here, and so I can go on now with my analysis here on the decision side. So the leak tightness was already filtered out in the context of buckling safety. Now we discuss not the leak tightness, so the diameter was also already filtered out. Now we discuss the diameter again in the context of the leak tightness. And there the team says, well, it is important that this tolerance is kept. So that this is a quite sensitive parameter. Therefore, the design team agrees to classify this as a significant characteristic. So a comment will be added here. I make it short. The idea is that here in this field, the important information can be found later. So it's a sensitive characteristic, and therefore to add more details here, we made this what we call a rich text field, where we can have bullet points or whatever, and also links in here. And this is now the decision of the team is now to say this is a significant characteristic. We say apply, and what happens now is that the diameter is becoming an SE characteristic. You see it here. You see it here in the current state. In the current state, the class is now an SE, and of course also the diameter up here. And when you're wondering why we decided here it's a robust design, but it's although an SE characteristic, then you can have a look at the classification back here, and you can see, there is a history behind. First, it was decided the safety factor is 10. That's why it was a robust. Then it was decided we have a sensitive characteristic. If you want to see the complete history of all classifications of all characteristics, then we have the history form sheet. You can reach it directly by clicking on this link here. Then a separate tab opens with the decision documentation, and I already had it open, so I need to update first. And you can see here for the diameter, the history from new to old downwards, and you can see the product characteristic is now an SE, classified by this user at this point of time with this comment here, and all relevant information is available here. This way, 1 second, I'm in the wrong form sheet. This way, you have to go through all the characteristics, and you are able to document these decisions. If you change a decision, for example, something like this, then the tool shows you something here is different to the last decision you've done, and now you have to decide whether you want to apply or to reset. Could be done by mistake. If you apply, a new entry in the history will be done, and the new class and comment, whatever, will be applied. If you say reset, nothing happens, and it sets this decision line back to the original value which was used before. So let me go on with the example now for the process special characteristics form, and the idea there is to make to use this form on the level where you create a process flow chart or a control plan. So let me go here to my elevator process, and just to show you quickly, this elevator process was created here with a process flow chart. So these system elements below were created in 1 flow. So a process flow is already existing, and we have these single process steps, and you saw that we made some FMEA here in the production of the hydraulic cylinder. The rest is empty, and so we will have the focus especially on these characteristics. So when we go now to our methods form, special characteristics process SC, we already have some process steps in here. And we have, the current state on the left and the decision state on the right now for filter number 3 and 4. And now we need to assign product characteristics and process characteristics. And this looks, for those of you who already know our control plan and process flow tool, this looks quite similar to them. And we also use, we also use here the process configurator to assign now product characteristics to process steps. So I click on the process configurator, which opens in a separate tab. And now I can use this functionality as it is known from the control plan and the process flow chart. The process steps are already there because I made this with, I created this with my 1 flow module, but I can also change the order and so on, as I can do it in control plan and PFC. And now the first step, which makes sense, would be to assign the product characteristics to the process steps. And of course, the first step should be to assign the special characteristics, the special product characteristics to my process steps. Therefore, I can use the classification filter here. I want to see all SCs and CCs. And the rest is not interesting, maybe, but I can also use them, assign them. I'm free with this. But for our example, I filter now, and I can see, okay, the material and the diameter. They are important. They are classified. And they are created in the production process of the hydraulic cylinder. So I assign these two specifications here to my process SC form sheet, just by selecting the PFC. Parallel, I added to the process flow chart right now. So just by selecting this checkbox here, or this drop-down entry, I assign it to my form sheet. I go back here, update it, and you can see the material and the diameter appear here as product characteristics with specification, with the current classification, and with the history here in my form sheet. Now I go back to my process configurator because I also want to add process characteristics here, the relevant ones. So I uncheck all to see all the unfiltered result. And then this is the usual way of assigning characteristics to also a control plan. So this procedure is the same. So I go to my process step here. That's the production of the hydraulic cylinder. And then I can see here I have the cutting speed and the feed rate as two process characteristics, which may be relevant here for my product. So I also assign it, and I can also, of course, assign the whole rest, but I'd like to keep this short. I go back to my form sheet, update it, and you can see now below the diameter here, the cutting speed and the feed rate are also mentioned as process, or additionally mentioned as process characteristics with their specification, and ready to be handled here with the decision. So I can go on here. The material was defined as an external class. I can confirm this once more from the production side. So I'm now in a separate team. Probably I like to confirm this. The functionality is exactly the same. I can apply this one more time. And then I have confirmed it. The button, apply button, turns green. For the diameter, this is an SC. Probably the production team says this is absolutely no problem. The product, the capability, the process capability is proven here. Capability proven. And so we talk about a robust production process. So we don't need to have a special characteristic in here. So we can apply this and filter it out again. And you can see back here the SC turns to a not classified characteristic. For the cutting speed, yeah, probably the cutting speed is it could be an externally classified parameter because yeah, your customer wants it. So coming from a customer complaint XYZ. So therefore the customer said you need to monitor the cutting speed. So this has to be a CC, and we are going to apply this. And the feed rate is a robust parameter. We have a robust production concept. Probably we're going to use this one here because there is only one feed rate on the machine or whatever reason, which should be then added here in this comment field. And then we can say apply and have this decision documented. So you can see I can have more than one decision for one characteristic coming from different functions, from different process steps. So this is all possible. And if you want to see the history here again, then I'm going to open this decision documentation. Now on the process side, shows you all decisions here for in this example now for the diameter, and all the histories and all the comments which argue these decisions. Yeah, that's it. This is how it works, and in our opinion, this is the first really systematic approach to have this documentation of special characteristics within a tool, within one data model, without any redundancies. So when I come to the conclusion now in my slide, then just to tell you the advantages of this method, then we have here a method which is orientated on the VDA approach, which is an accepted approach since for more than 10 years now. We have all information which is used here in one tool and one database, so we don't have any redundancies. We don't have to copy characteristics from one tool to the other. We have no redundant data, and we have a systematic, transparent documentation of the decisions on special characteristics. So we can always see what we decided, when, who, and why. And if we have later some changes, we have a minimum effort for changes or additions.